By the end of this video, you will have an understanding of how to make a camera follow your player smoothly using Unity and C#. For the best tips and tricks on game programming and game development, subscribe to my channel and hit the bell to be notified when I post new videos every Monday. If you are already a subscriber, thank you. It really means the world to me. My name is George Wulfers and I'm a professional game developer. Let me guide you on your game development journey. Be sure to watch this video to the end to find out how you can get more free learning resources. Step number 1. What is a follow camera and the purpose of it? Alright, so what is a follow camera? And this is something we probably should have touched on a little bit last video, but I guess now is a great time for me to talk a little bit about what that is. In most videos, in most video games, you have a player where he walks through the environment, and in order for you to be able to see that player, the camera has to follow it, right? So that's pretty much what it is. In 2D games, usually, since we only have two coordinates, x and y, we're looking at a side angle of the player. But usually another name for this type of camera can be called chase camera, which I believe I think it was like 10 years ago when I learned how to program and make games. The chase camera I think that term was more known. Now people just call it follow cameras, which is the same thing. It just chases you. And there's different types of follow cameras as well. It all depends on the effect, essentially, that you want to convey when you're creating the game, or the feel that you want to produce, I guess. So the first camera, like the one we did last time, it always looks at the player no matter where he is, and it doesn't gradually move. It's just fixed on it, and this type of camera is not bad. But if we wanted to create a camera like Super Mario, where when you walk. So I guess in Super Mario, if you haven't played it, it allows you to have a space where the camera doesn't follow you if you're near the center of the screen. Once you get farther than the center of the screen, maybe, I don't know, whatever distance you want to apply to it, it then starts tracking you and moves slowly towards you. So let's say that my head would be where the player is, and my hands would be the regions where once my head reaches this area, the camera would follow this way. So yeah, hope that makes sense. You'll see what I'm talking about when we get into the code. But now I've seen most people that create these camera systems, or cameras, because it's not really a system, it's just a camera, that they attach it to the actual object that they're following. And for some cases this is fine, but if you ever want to be like, tell the camera, okay, don't follow this person anymore, something happened, I want you to go on this area of the map and show the player what's there, or maybe have a cutscene, that's going to be harder for you to implement because the camera is now attached to an object. So now you have to unattach it, and the reason why people do this, that they attach the camera to the object, is because of, if it's in a hierarchy instead of an object, if you're just moving that object, that camera is going to automatically move with that object, so you don't have to implement all this code. But if you want it to be more diverse and have this camera change positions and locations, then that's going to be more complicated and for you if you're going that route. So the way I'm planning on having this camera work is we're going to tell it, okay, based on whatever event is happening, we want you to follow this person. But if something else happens, then I want you to follow this other person. And because we never attached our camera to an object like that, it's going to be much easier for us to actually implement that code because we don't have to worry about attaching, detaching, and all that stuff. We already have a code base, a set standard, I guess, of how it behaves. So we just gotta tell it, okay, just change the object that it's registered to, and it'll automatically go and find that object and pretty much follow it. And later on, after we're done with this camera, we're gonna have multiple cameras. Or that's something that I'm planning on doing, where based on events again, we're gonna have a camera system that tells what camera needs to be active at certain points. We don't need a camera system. We could just do it with one camera and based on the match manager state, move that camera to certain locations. We'll see how that works. Maybe we won't need it, but if I feel like it would be a nice introduction to a camera system, then we would implement that. Step number 2, modifying the current camera follow script.
Okay, so let's open up our Unity project and we're going to go into the scripts, gameplay, camera, open up the follow camera, and let's modify it so that we have a better camera that follows you based on speed and stuff like that. So we're going to get this and delete that whole thing. All right, so there's a lot here that is new, and there's a lot here that is not new. So let's go from the top. We instead of using a game object, we're just going to be getting the actual transform so that we don't fetch for the transform every frame because that um, can be slow. So we want to make sure that we just have the transform of whatever we're following, and that's it. The next one is the same thing. It's just to follow Z offset, which means that we're going to follow that object. We're going to follow and keep a distance uh, in the Z direction. Okay, so that we don't end up in the same space. Then we're gonna have two new things. This is the I didn't really know what to name it, so I just named it width safe area and height safe area. Those are the margins, I guess you can call it. We're gonna have two on a positive and a negative on the camera. So let's say that this whole screen that you're watching the video through is the viewport or the camera screen in your game. Let's say that we are calculating this safe area based on the center of that screen. So if we have 10 by 5, we're going to be probably around here on the 10. So it's going to be positive 10 and negative 10. And then you're going to have the height as well. It's going to be positive 5, negative 5. So you're going to have essentially a box where the player can move around freely without the camera moving. So whenever that player leaves that box, we're going to start following that player. And that's how that works. So I wasn't really, I don't know exactly if we want 10 in this side and then 10 in this side, or if we want to just get 10 and do 5 and 5 on the positive and negative. Same thing for the height. So we can just, it doesn't really matter because if you just want half and half, instead of saying 10, you're just going to say 5 and it'll be 5 and 5. So that's 10 essentially. But I don't know how we want to allow people to think about this. We might just for now say that it's going to be 10 and 10. Um, but we'll see. Anyway, so the next thing we have is a float for the speed of the camera. This is going to be how fast the camera is going to move every frame. And for now, we just set it to 10, but we can set it whatever once we start playing with it. And then we have a velocity S in the player. Um, and the last thing is the drag. So those two, actually those three things, the final three things there, you've already seen. Hopefully, if you haven't seen it, go back to those previous episodes on the movement controller for the player, and we explain, well, I don't think we explain in more detail, but we explain this as the same thing. It's pretty much what we did when we were moving the player. Except that one has gravity. This one is not going to have gravity, otherwise the camera would always be falling and it wouldn't be able to fly. And we want our camera to fly. Okay, so as we know, we want to have any physics calculations within the fixed update because it runs at a specific rate, unlike the update function where it runs based on your PC's capacity to run. So the first thing we want to do is we want to make sure that we have a transform. Remember, this is a reference to the object, so that so it can be null or empty, and if we try to access something that is empty, we can crash our game. So make sure that you're always putting guards against that, right? So then we're going to get our initial or current positions. So we're going to get the position from the follow transform and from the camera's transform. Okay, we called it follow P and old P. Both of these are going to be vector 3s because we still want to keep track of that Z, even though we're not using it, but we kind of are to just offset that camera. We still want to keep it. And then we're gonna we're gonna see how far the player is from that center point. So that's a pretty easy calculation. Is just the difference between the uh, where we want to be, where we were going to be looking at, which is the player position or whatever object we're following, that x minus the rx or the current x. Um, and we do that for the x and the y. Yes, you can just do the whole vector and just take out the x's from there, but we did it this way. You could probably do it in one line and it'll be fine, except you would have to account for this. So what abs is just taking the absolute number of or value, the absolute value of whatever the remainder is here, whatever that difference is. And the reason we're doing that is because we don't really care um, if it's negative or positive here. We just care we want a positive number so that we, so remember we have from here to here as positive and from here to here that's negative. Um, we just want to make sure that wherever we're looking at, whether it's from here to here or from here to here, we always want to make sure that it's positive, so it's easier for us to actually do our calculations. and so that we can only look at to see if it's greater than and not less than. So if we didn't do abs, we would probably need to do a greater than and a less than. So we would have essentially here four different calculations or checks to see if it meets the criteria that we're looking for. So that's why we're using the absolute value there. So then if it is outside of the area in either direction, we're going to calculate the direction to the the player or the object that we're trying to follow so that we can go that way. Okay, so that's a pretty easy calculation, which is just the difference, which we did it here. Um, but we want to normalize that so that we get a number from 0 to 1 or -1. So if it's -1, we're going to go to the left or down. And if it's positive, we're going to go to the right or up. And so that's pretty much what we're doing there. We're just getting the direction to the player. And make sure that if you're getting any direction ever, it is always going to be where you want to go minus where you are. Because if you do it backwards, it'll point the other direction, so you're going to have to flip it eventually. So that we just get the reason why I did speed equals camera speed is because when I was programming this, um, and you'll see probably later on, there's an issue that we have. I don't know how we want to handle this, but there's an issue that we have where whenever the player falls for too long, the camera, because of the speed, it can't reach the player fast enough. And that's why I had it here so that whenever that was true, we could speed up the camera, but it wasn't working right. So I need to figure that one out before I show you guys how to do it because right now it's not working properly. So the next thing is just we're going to calculate what the acceleration is, which is just going to be the direction times the speed. And we're going to apply our drag, which is just going to be multiplying the drag negated times the velocity and just add it to the acceleration, thus braking, slowing us down. And this is the equation where we calculate the new position based on the old position related to the velocity and the acceleration that we're going at. Um, Same thing here, we're just calculating the velocity. And then in this line, we're just making sure that we're staying at a distance in the z-axis, and then we're just setting it back to us.
All right, guys. So I hope everything it's making sense so far. If you have a question, please comment below and let me know what types of cameras have you used or implemented in the past, and if you're having any issues, let me know. Step number 3: testing the current code and setting everything up.
All right, so let's go now back to Unity, and we just have to make sure that we set up the camera properly. Let's drag in our player into the follow transform. We're going to keep the z offset as -1. We're going to keep the safe area, let's do 5, and for the height, let's do 2.5. For the speed, we're going to, well, actually for the drag is going to be 2.5. We want to make sure that it's the same or similar to the player so that we're not going faster or slower than the player. Eventually, maybe we want to um, create some kind of object that holds all of the physics physics things so that it's global for that level. And then anybody can just access that information and we don't have to recreate it. But for now, we just have to make sure that it's the same. For the speed, we want to go a little bit faster, slower, depending on what we want. Let's do a little bit faster, 12.5, then the player. And now the camera's ready to be used. So let's go here. And actually, before we do that, let's get this guy and bring it down, maybe put it here, and let's make it bigger so that we have a bigger play area, essentially. So let's do 20 right there, and we're just going to extend the bounds to cover the whole object. And then we're going to copy and paste it, move it slightly this way, maybe like that. And then we can just move these. Something like that, I don't know. All right, save that, play. And we can see that it follows us. And we have a pretty good area to just walk around and not have the actual camera follow us. But whenever we get outside of that area, it does follow us. So that's pretty cool. I think I put these too high. But there we have it. Now if you guys want to see it, the issue that I was talking about, let's go ahead and fall. And you can see that it follows us, but it's not fast enough. And if you look at the player, like if you look at the velocity, you can totally tell that they're falling at different rates. And ours capped at -4, and I think I know why that might be. Yeah, so that's because we're applying drag to the X and the Y. I think that's going to be an issue for another day because we don't really need to worry about it now. We have a working follow camera.
Congratulations! Now you know how to make a camera follow your player smoothly using Unity and C#. If you would like to follow along, I have provided a link to our project in the description below. Don't forget to also get our free guide where we explain in more detail about cameras and camera systems in the description below. Don't forget to go to our Facebook page and say hello. We'd love to hear from you. Check out these other videos next on how to make games using Unity. And if you like this video, hit that like button and be sure to subscribe and share this with your friends. Thanks for watching and see you next week.